As always, in order to save time, I just prepare the code. Now I will copy the code and paste it here. Then we will see it line by line. Now I just paste it here. This is the code I just prepared. Now let's see line by line. An example of PCA implementation based on the procedure and the steps outlined above. Namely, in the previous section, in the introduction of the principal component analysis, we have talked about the procedures and the steps of the principal component analysis. Especially, we have explained the mathematical foundation of the PCA. At that time, we have seen that we have several steps. Namely, we need to follow several steps. First, we need to standardize the data. Second, we need to calculate the covariance matrices. Third, we need to decompose the covariance matrices into eigenvalues and the eigenvectors. Namely, we have seen these kind of steps. Now, based on those steps, I am going to explain this example. Now, in the first step, I just imported necessary libraries, namely imported NumPy, Pandas, Matplot library, then imported sklearn.preprocessing standard Scala because we are going to standardize the data. Therefore, we just imported this. Step 2, just generated a data set with two features that have some degree of correlation because we are going to apply the principal component analysis to a data set which have two features, and that features have some kind of redundant information, namely some kind of correlated information. As a result of the principal component analysis, finally we are going to get two new features. That new two features will be independent or uncorrelated. In other words, they are orthogonal. Therefore, we just creating a data set with two features. The two features have some kind of relationship. Now, let's see here. In the step 2, we are going to create a data set. Ensure that each run, we need to get the same, namely consistent results. Therefore, I just pass it to a seed, namely 42. Now, let's see the first feature. Here, we are generating the first feature by using the numpy.random.normal. Then passing three parameters here. The first parameter will be the mean of the feature. Second parameter is the standard deviation. The third parameter is the number of the items in the feature. Therefore, in this feature, mean is 10, standard deviation 3. Actually, I can pass here 0, then pass 1, and I can generate a feature, namely a standardized feature. But I didn't do that because I am going to use this standard Scala class, going to standardize data as a first step because we just explained it in the introduction of the principal component analysis. Based on the principal component analysis steps, we are doing this example. Therefore, I intentionally created a feature, namely the first feature, its mean is 10, standard deviation is 3. Then this is the second feature because we are going to create a data set with two features that have some degree of correlations. Therefore, in the second feature, namely during the creation of the second feature, we just use on the first feature, multiply it by 0.8, namely a correlation factor of 0.85, then adding some noise here. Then we just created the second feature. Now we have the two features. Let's combine and create a data frame, because if we create a data frame, we can process it easily. Therefore, I just name it the first feature x1 and the second feature as x2 in the data frame. This is the resultant df underscore original. Namely, this is the original data frame derived from the feature 1 and the feature 2. Now we have the data set. Okay, based on the procedure we have learned in the introduction, we are going to do this example. Before that, let's check the data. What kind of data we have been created? Okay, therefore I just comment on this portion, just comment on this, and if I run the code, because here I am going to see the newly created data frame underscore original, namely I am going to see the original data set with x1 and the x2 features, namely the first 5 recorders, because I am using here df original.head. Previous lectures we have seen this function, therefore just run this. This is the original data set we just created. These are the values of the first feature. These are the items of values of the second feature. Okay, now let's see the other steps. Just uncomment this and let's continue. Step 3. In the previous section, we mentioned that after we have the data set, we need to standardize the data. Therefore, in the step 3, we are standardizing the data, namely mean, centering, and the scaling to unit variances. We have created feature 1, created feature 2, but their mean are not 0, their standard deviations are not 1. Therefore, in this step, we are going to standardize the data and make their mean equal to 0 and their standard deviation will be 1. Therefore, we are going to do that kind of pre-processing step. Okay. First, I just initiate the standard Scala class and get the Scala. This is the instance. We know that Scala instance has fit and the transform function. Therefore, by using the fit underscore transform function, we just pass the original data set to this function, and then we just get this data underscore standardized. Namely, this is the data standardized. Actually, this data's type is NumPy. Therefore, we need to create a data frame by using this standardized data. Namely, convert the standardized NumPy array back to a data frame, because if we create data frame is very easy to manage, because we are going to calculate some kind of correlation or other things, as therefore we create again a data frame by using the standardized data. Here, this is the first feature, this is the second feature. I just changed it because this is the standardized feature, therefore x1 underscore standardized. Then this is the standardized second feature. We just name it x2 underscore standardized. Okay, now this is the standardized data set. Okay, now let's see the standardized data set as well. I just comment out this. Just comment out again and run the code, see the result. Because here we are going to see first 5 rows of the standardized data. This is the original data. This is the standardized data. Namely, here the mean is 0, standard deviation is 1. Okay, now let's come here and open it, uncomment this. Let's continue the explanation. In the step 4, we have get the data. Now we have the data, standardized data in hand. Using numpy's dot covariance matrix, this function, we can create the covariance matrix. This is a transpose. We are passing the data set, standardized data set. Therefore, we are getting the covariance matrix. Actually, this covariance matrix type also numpy.array. Namely, this will give us ND array, numpy's ND array. Then, in the next step, step 6, we need to decompose the covariance matrices into eigenvalues and the eigenvectors. In the previous section, we mentioned that After we get the covariance matrices, we need to decompose it eigenvalues and eigenvectors, because we are going to find the variances, namely variances, direction and amount of the variance. Which direction we have the most large variances. Therefore, we are going to find it. In this step, we just decompose the covariance matrices. The results are NumPy array as well. Namely, based on this formula. Namely, this is covariance matrix and this is the eigenvalue and this is the eigenvector. By using the numpy's.linear-algebra.eigen and we get the results. Namely, first result is eigenvalues, then we have the result eigenvectors. Namely, this covariance matrix, by calling this function, decompose it into eigenvalues and eigenvectors. Now, we will use these two values in the next step. In the step 7, we just compute the proportion of the variance explained by each principal components. First, we just calculate the total variance, because eigenvalues explain the variances, then eigenvectors explain the direction of the principal components. Therefore, first we get the total variances. Namely, by using these eigenvalues, by using this NumPy sum function, we just get the total variances. We know that what is variance, because the principal component analysis relies on the variance. In the previous section, we have seen what is variance. Then, by using eigenvalues divided by this total variance, we are getting the explained variance ratio. Namely, the first principal component occupies how much information, the second principal component occupies how much information. Namely, this is explained variance ratio. Step 8. Transform the data into principal components. Now, we have eigenvalues, eigenvectors, we have total variance, we have explained variance ratio, we have all things now. Then, especially, we have here eigenvectors, because this is the transformation process. Namely, we have here eigenvectors, then we have here a specific feature. This is the standardized data frame, then taking the dot product between these values and the eigenvectors, we are getting the principal components. Namely, we are just implementing this equation, this formula. Actually, this is also numpy.nd array. Then in the step 9, converting the principal component, namely this is the principal component, into a data frame for other processor. In this result, now we have two components actually, the first principal component and the second principal component. Namely, I am going to create a data frame using the name, for example, column name PC1 or PC2 in order to ease understanding. Therefore, I am just creating a data frame by using this principal component, namely by using this result, just like this. Principal component, we are passing it, then column names will be PCA1, the first principal component, second principal component. Now, this is the final result, namely this is the data frame. Data frame, principal component analysis, and the components. Therefore, this is the final result. Here in this result, we have two columns. The first column is first principal component and the second column is the second principal component. In the following section, I will print all information, namely display covariance matrices, eigenvalues, eigenvectors, and explained variance ratio. First, let's display the covariance matrix. These are the column names and these are the index names. Then, in this step, I just displaying the eigenvalues. In the case of eigenvalue, the first is, for example, I just name it principal component 1, principal component 2. These are the index name. Later we will see. And I am printing this as a format of just like this. We will see later. Then we are displaying the explained variance ratio, because we have two principal components here, the first principal component and the second principal component. The first zero index give us the first principal components explained variance ratio, and index 1 gives us the second principal components explained variance ratio. Then I just multiply it by 100, namely I am changing it to percentage. Then here I just print on the first 5 row of the resultant principal component, namely we just created this, print on the first 5 row because we know this function. Then actually these are the information we just printed. This information related to the covariance matrices, eigenvalues, eigenvectors, and the explained variance ratio, and the principal components, the first 5 rows. Okay, then we are going to display other information. Step 11, visualize the scatter plot side by side. Namely, until here we have 3 data sets. The first data set is the original data set. After we get the original data frame, by using the standardization, we get the second data frame, namely df underscore standard. Namely, this is the standardized data set. After we get the standardized data set, we just calculate the principal component analysis. As therefore, in this section, I will show 2 scatter plots. First one for the standardized data set, namely df underscore std. This is the first feature, standardized feature. This is the second feature. Then we are just plotting it. Namely, we are just plotting its scatter plot. Then in the second scatter plot, we are displaying the result. Namely, the result of the principal component analysis. This is the first component, second principal component. Namely, horizontal axis representing the first principal component, vertical axis, y-axis represent the second principal component. We have here title is standardized data scatter plot, then principal component scatter. Finally, we are displaying the data. Finally, here we are showing the data. Before run this, summarize it real quick. In the first step, imported necessary libraries. In the second step, just created a data set with 2 features. In the step 3, we just standardized the data. In the step 4, we just created a data frame by using the standardized data set. In the step 5, calculated the covariance matrices. Step 6, decompose the covariance matrices. Step 7, calculate the total variance and the explained variance ratio. Step 8, we just converted or transformed the data into the principal component by using the eigenvectors, by using this formula. Step 9, we just create the final data frame, namely df underscore PCA components, by using the principal component results. And then we just displaying some related information. Finally, we have displayed 2 scatter plots, one for the original standardized data, one for the principal component analysis, namely one for the result of the principal component analysis, namely final result. Now let's run the code and see the result. This is the result. First, we just displayed the original data. These are the original data. First feature, second feature, namely random features. These features mean values not 0 and their standard deviations are not equal to 1. After we standardize data, we just created this standardized data set. Namely, we have here 2 features, x1 standardized, x2 standardized. Actually, this is the original. In the step, we just standardize the data, as therefore mean is 0, standard deviation 1. Then in this step, we just create the covariance matrices, and it's a symmetric matrix. After we create the covariance matrices, we decompose it into eigenvalues and eigenvectors. These are the eigenvalues, namely this is the first eigenvalue, this is the second eigenvalue, lambda 1, lambda 2, then these are the eigenvectors, namely V matrix PCA 1, PCA2 component, one first component, second component, and then these are the eigenvectors. After that, we just get the exponent variances. Namely, first principal component occupies 86.81% of the all information of variance. Second principal component occupies certain 0.19% of the variances. Namely, 100 information here divided into principal components. We just display this kind of statistics here. Then this is the principal components. This is the first principal component, namely the first 5 rows. This is the second principal component, first 5 rows. These data are different from these data. Completely different, actually. Now, let's see the scatter plots. In the scatter plot, horizontal axis represents the standardized X1 feature. Vertical axis represents the standardized second feature, namely X2 feature. We have some kind of correlation relationship between these two features. This is the standardized original dataset, namely original features. They have some degree of correlation between them. Therefore, we get this kind of scatter plot. Namely, this scatter plot has a kind of direction. I show some kind of linear relationship between this X1 STD and the X2 STD. This is the result of the principal component. Namely, after we project the data into the principal component space, we get this scatter plot. The horizontal axis represents the first principal component. Vertical axis represents the second principal component. They don't have any linear relationship. They are orthogonal or they are uncorrelated. Therefore, these are the results. In summary, there we can see some kind of relationship between these two features, but in this scatter plot, we don't see any kind of linear relationship between these two features. Therefore, after we calculate the principal component analysis, each feature will become independent, will become orthogonal. Namely, redundant data will be removed. Now, let's see the second example.